Besides the organelles that are found in all cells, and besides the three types of organelles that are found in eukaryotic cells, there are also some organelles that are found in only some cells. We're going to go through a couple of those. One example are the lysosomes. These are vesicles, spherical organelles that carry molecules that are carrying specifically enzymes that break down macromolecules. Lysosomes are found in most animal cells, some plant cells, and what they do is kind of roam about the cell, encountering those molecules that are broken down or molecules that aren't working anymore. They break them down into little particles, into the monomers, so that the cell can use them to build macromolecules. They also might encounter an invading bacterium or another invading organism. And again, they will break down or lyse, cut, thus their name, the lysosomes. They will cut up into small pieces things that they find in the cell. Another type of organelle that's found in some cells is something we call cell walls. The diagram is now changed to a characterization of a plant cell. Plant cells, in addition to their membranes around the plant cell, will have an additional layer of, in the case of plants, cellulose. In the case of fungi, they will have chitin that surrounds the cell, creating a box that the cell is actually found in. It's one of these boxes, for example, that Robert Hooke, when he's looking through a microscope and sees something that he calls a cell for the first time in the middle of the 17th century, he was actually looking at one of these structures made by a cell wall. The cells of cork had already been drained of their cells. All that remained were the cell walls. The purpose of the cell wall is actually for strength for the plant or the fungus. The cell itself is got a plasma membrane that's kind of mushy. Well, the cell wall gives it strength so that it can support, for example, the structure of a tree. Another function of it, by the way, is for protection, because that's an additional barrier for things to get into the cell. A third specialized organelle that's found in plants and algae are the chloroplasts. A chloroplast is a kidney bean-shaped organelle, kind of similar in shape to the mitochondria. In this case, however, the mitochondrion, if you remember, has two membranes surrounding it. The chloroplast actually has three membranes surrounding it. There's an outer membrane giving that kidney bean shape. There's a second membrane inside that also has the same shape. And then there's a third membrane that's extremely complex, folded in very interesting ways. They kind of look like stacked pancakes or coins on the inside of the cell, but producing a tremendous amount of surface area for metabolism. The purpose of the chloroplast is actually for photosynthesis. We're going to have in a future chapter and a closer examination of photosynthesis, which requires lots of molecules working in combination, lots of molecules that have to be arranged in a particular order for the steps of photosynthesis to be done in the proper order. It requires a tremendous amount of surface area to mount all of those molecules. And that surface area is produced by this third or innermost, what's called thylakoid membrane of the chloroplast. A fourth specialized organelle that's found in many plant cells, a few of the animal cells, cells that could use this kind of thing, is something called a vacuole. It's more or less kind of equivalent to a warehouse, a storage area. It is surrounded by a membrane, but inside there's basically water in there where the cell can store food, for example, that it might need, or it can store waste in there, or it can actually store water in there that the cell might be able to use. The purpose is in all cases for storage of things for the cell. Now, there are other organelles that are found in various and sundry specialized cells, but those are the commonest kinds of organelles found in cells. Going back to our diagram of the organizational hierarchy of life, remember we looked at 3 levels of hierarchy below the biological hierarchy found in all organisms. Subatomic particles are arranged into atoms. Atoms are arranged into molecules. Molecules in organisms are arranged into metabolism. All cells, regardless of the type of cell, have metabolism going on. If it's a very small cell, like a bacterial cell, then in fact it's only got metabolism and a cell structure, and there's no further organizational hierarchy. Because it's a small cell, it's only got, we'll say, 5 levels of organizational hierarchy: subatomic particles, atoms, molecules, metabolism, and the cell itself. As you get larger cells, still one-celled, you need to put organelles within the cell, and so we have organelles in the cell as well. That gives 6 levels of hierarchy for those kinds of things: subatomic particles, atoms, molecules, metabolism, and then inserted between the metabolism and the cell would be organelles. Then when you get to larger organisms that actually require more than one cell because they are much larger than can be accommodated by a single cell, then as you increase the number of cells, you add additional tiers of biological hierarchy. To understand a little bit of what that means and kind of the consequences, there are a couple of interesting spiritual or biblical examples that we could look at. When Moses returned to Mount Sinai with all the people of Israel, he left his father-in-law in Midian and went off to Egypt and came back with 2.5 million people. Interesting when we've come for dinner. Really amazing situation here. His father-in-law, the priest of Midian, Jethro, goes out to meet his son-in-law. It's been a few months since Moses left, and the day after they met, Jethro, his father-in-law, sat down and watched Moses throughout the next day. The people of Israel came to Moses with their concerns, they had disputes, and so he would settle their disputes. They had concerns about perhaps how food was being distributed. He would take care of that. Any concerns people had, they came to Moses, and apparently they lined up, and for all day, Moses is sitting there dealing with the various concerns and disputes of the people of Israel, apparently late into the night. Because at the end of this, actually the following day, when Jethro is ready to leave, he says to Moses, if you keep this up, if you don't change this situation, you're going to be worn out. You're going to work yourself to death here. You need to change the situation because you can't sit here all day long and settle the disputes of millions of people. You got other things to do. He suggested that given how many people there were in Israel, that he needed to create a hierarchical system of judges, that over every 5 people or 10 people, he'd appoint a judge over that group, and they would take their concerns to that judge. If that judge wasn't able to deal with it, he would appoint judges over them that would take the more important or more difficult concerns. And then there were judges over those that would take more important concerns. And then finally, way up at the top, anything that no one else could solve, those things would go to Moses. So Moses wouldn't get besieged with hundreds and hundreds and hundreds of concerns during the day, maybe only with one major concern. That was a hierarchy of organization. And how many levels of hierarchy was actually determined by how many people there were. If there were only a few people, you might only need one tier of hierarchy, one level of hierarchy. If there were more people, you might need 2. If there were many people, millions, you might need 4 or 5 levels of hierarchy. Another example would be Jesus when he is feeding the 4,000 or the 5,000. Jesus is breaking bread and passing them to the disciples, and they're going out to thousands of people. Well, how do you do that? Jesus had them sit in 50s and 100s, and what is he doing there? Well, he's creating an organizational hierarchy. He's got 12 disciples. So if you divide the people into 12 major groups, each disciple can take the food to that group. But in that large group, you choose smaller subgroups, and somebody will distribute it to all of those people in that particular group, subgroup, and then in those subgroups you divide it further. Depending on how many people, you got 4,000 people, you might have 3 tiers of organization. In that fashion, you can efficiently move food out and feed the maximum number of people. The principle is that you can distribute food or collect waste or deal with political concerns of large numbers of people by dividing them up into successively smaller groups, creating an organizational tiers of hierarchy. And the same sort of thing is done in biology. Depending on the size of the organism and the number of cells that the organism has, the organisms are divided up into various higher level tiers of organization above the level of cells. If you got 1 cell, you don't need another level of organization. That is the whole organism, the single cell. But if you've got maybe 100 cells, you might want to add another level of organization so that you can spread out food to all the cells, so that you can spread out oxygen or carbon dioxide to all of the cells, or you can collect waste from all of the cells to get rid of it from the organism. In order to be most efficient about meeting the needs of all of the cells, you might need to put in additional tiers of hierarchy. By the time you get to something like a human being with trillions, literally trillions of cells, it turns out that there are as many as 4 other tiers of hierarchy above the level of cells. Cells are organized into tissues. We have hundreds and hundreds of tissue types in our body. Each tissue is made up of a number of different cells that interact together in that tissue. Then tissues are organized into a larger organization, into what are called organs. So for example, heart tissue is made up of a number of different kinds of cells that combined actually make up one of the tissues that make up a heart. So there might be cardiac muscle tissue in the heart, plus tissue for the valves of the heart, plus tissue for what's called the pacemaker of the heart that receives electrical impulses and sends them out, plus tissue for adipose tissue for fat in the heart in order to protect it in case of injury. There's a number of different tissues that combine to make the organ known as the heart. Then at a higher level of organization, the heart is combined with veins and arteries and capillaries to produce a system of organs, an organ system, in this case a circulatory system. And then those multiple body systems, the circulatory system, the urinary system, the skeletal system, the muscle system, all of these systems of the body combine to produce the human body. Because there are trillions of cells, you need an additional 4 levels of organization in order to meet the needs of all the cells, to make sure that all the cells get the oxygen they need, to make sure that you collect all the carbon dioxide from those cells to take it out of the body, to make sure that all the cells get the food they need, and so on and so forth. The organizational hierarchy that we find in organisms is, again, universal. No matter what the organism is, it's got at least, gets to the organisms of the biological world, it's got at least 5 levels of organization. Humans, probably some of the most complex of organisms, actually have 5, 6, 7, 8, 9, 10 levels of organization because of how many cells they have. This is an example, one among many, of the kinds of hierarchy that you find in biology. Hierarchy that's reflective of the hierarchy that we find in the Godhead.